Good morning everyone. This is Pranay Kishore and I would be recording this video as a part of my video assignment for the course EE230. So let's look further what I would be discussing in this video. So the problem I would be discussing in this video assignment is the Banach match problem, whose problem statement is as follows. At all times, a pipe smoking person carries two matchboxes, one in his left hand pocket, one in his right hand pocket. Each time he needs a match, he is equally likely to take it from either pocket. Consider the moment when the person first discovers that one of his matchboxes is empty. If it is assumed that both matchboxes initially contain n matches, what is the probability that exactly k matches are there in the other box, where k can be anything from 0 to n? Concept used in solving the problem. So the concept used in solving the aforesaid problem is the negative binomial random variable, which is the number of trials required for getting R successes in a Bernoulli trial, and the probability mass function for it is as follows. Probability for getting R successes in n trial, Rth success in nth trial is equal to n minus 1 CR minus 1 p to the power R into 1 minus p to the power n minus R, where p is the probability of success in each independent trial, R is the required number of successes, and x is the number of trials required. Now let's see how we are getting this expression. So for getting Rth success in nth trial, we need to have the first R minus 1 successes in previous n minus 1 trials. So the rest n minus 1 minus R minus 1 which is equal to n minus R trials would be failure. So by assumed independence of trial, the probability of R minus 1 successes in R n minus 1 trials will be p to the power R minus 1 into 1 minus p to the power n minus R. Now for these R minus 1 successes, there are n minus 1 C R minus 1 possible sequences in the n minus 1 trials. Hence, the probability of R minus 1 successes in n minus 1 trials would be n minus 1 C R minus 1 into p to the power R minus 1 into 1 minus p to the power n minus R. Also, the nth trial is supposed to be a success for our original problem. Hence, we multiply the previous expression by p and we get a final expression as probability of Rth success in nth trial equal to n minus 1 C R minus 1 into p to the power R into 1 minus p to the power n minus R, where n is always greater than equal to R. Now let's look at some highlights and key points. So there are n matchboxes, and there are n matches, and there are two matchboxes, and choosing either boxes is equally likely. And we are supposed to find the probability that when first empty matchbox is discovered, what is the probability that other matchbox has k matches, where k can be anything from 0 to n, and is the maximum number of matches. So let's look further into the solution now. Here in this problem, we can see there are two possible events, and let those events be E1 and E2. So the first event, E1, corresponds to when the person finds his right hand pocket matchbox empty first, with some k match left in the other matchbox, where k can be anything from 0 to n. And the second event, E2, corresponds to when person finds his left hand pocket matchbox empty first, with some k match left in the other matchbox, where k can be anything from 0 to n. Now, let's look further into the solution. In the problem statement, it's mentioned that the person is equally likely to take the match from either of his pockets. So we can see that probability of each random trial of choosing the matchbox for taking the match is half. So from here, we can also conclude that probability of event E1 and E2 happening are both equal, as person is choosing the matchboxes with equal probability. So once we find the probability of any of the events E1 or E2, the probability of the final probability would be just double of it. So probability of event E happening would be equal to twice probability of event E1 happening, which is equal to twice probability of event E2 happening, where E is the event of discovering first empty matchbox with k matches in other matchbox. Let's assume event E1 has occurred. Then this event will only occur if for the n plus 1th time we have chosen the right side pocket matchbox, and now as there would be some k matches left in the other matchbox, so total number of trials that are made up to this point is n plus 1 for the right side and n minus k for the left side. So which gives us the total number of trials as 2n plus 1 minus k trials. Here Rth success corresponds to selecting the right matchbox for n plus 1th time. So the R for our original expression for the negative random variable mass probability mass function is equal to n plus 1. Here P is the probability of selecting a matchbox, which will be half, as it is equally likely to choose both either of the boxes. So putting these values in the negative random variable probability mass function, which we have seen earlier also and which is given here also. So the probability of event E1 happening is equal to 2n minus k Cn half to the power n into 1 minus half to the power n plus 1 minus k, which comes out to be 2n minus k Cn half to the power 2n minus k plus 1. Since we have seen that probability of event E2 happening will also be same as probability of event E1, as choosing either boxes is equally likely. So the probability of event E happening is twice the probability of event E1 happening, which will give us the final expression as 2n minus k Cn half to the power n minus k. This was it from my side. Hope I have delivered it properly. Thank you.